Hey, welcome back. So we're going to go ahead and apply our knowledge now. So all this sort of egghead talk about intermolecular forces, and the question is, how do we know? Why do we care? So here's two molecules. Here's formaldehyde, and here's ethane, and CH2O, C2H6. So the molar masses, they're almost identical, right? They're all about 30 and a bit grams per mole. So the question is, which one will have the largest boiling point? And the very first thing you've got to do is you mustn't just run out and Google the answer or look in the CRC handbook what the answer is. You must ask yourself, what does this really mean? So when it says which one has the largest boiling point, it's really on about intermolecular forces. And it's really asking which one will have the strongest intermolecular force, because the more tightly held together they are, the harder it is to boil, so the higher the temperature has to be. So if we look at these, right, we can remember we've got those London dispersion forces. The London forces, remember, scale as the number of electrons, or if you like, they scale as the molar mass. So bigger molecules have more electrons. So if we look at these two, and we can look and we can say, well, the London forces would be about the same. And so we might go ahead and say, well, oh gosh, I remember the surface area, right? So this molecule here looks like it's got a bigger surface area than this one here, maybe. So maybe the bottom one has stronger intermolecular forces. But unfortunately, we are missing the big point here. And the big point here is that one of these molecules actually has an additional intermolecular force. And when we look at these two structures, the first thing we should notice is that there's a whopping great big carbon-oxygen bond here. And carbon and oxygen have very different electronegativities. Oxygen is 3.5. Carbon is 2.5, so that difference is 1.0, and that gives rise to a whopping great big dipole moment. And if we look at the CH bonds, right, we've said earlier that their electronegativities are almost the same. So carbon is 2.5 and hydrogen is 2.1. That difference is just 0.4. And we're going to say that's really pretty much just nonpolar covalent. That is so wimpy. We're going to go ahead and say that, yeah, technically the carbon has a slight negative charge on. It's like having a slight 2 cents a year raise or something. You're not really making much more money. So the formaldehyde's got a dipole moment. So what does that mean? That means that the formaldehyde molecules are going to stick together through that dipole-dipole interaction, right? So they are going to go ahead and pile one on top of the other. So like so. Oh my gosh, this is just terrible. And they are going to stick together, right? And they're going to stick together through this dipole-dipole intermolecular force. And that's going to cause them to be held together pretty strongly, which means that their boiling point's going to go up. So the ethane molecules, right, they have that very low, wimpy intermolecular force. Well, it's just London. London can actually be quite strong, but clearly both molecules have the same size, so they'll be equally strong in the London forces. But they have a ringer, right? They have that dipole-dipole interaction for formaldehyde's sake, and that's going to make it stick together and be harder to boil. So the boiling point's going to be bigger. Did you get it?